Hey guys, two new formulas to practice today. Very easy problems. Let's look at the first one. The integral of the natural log of 5x plus 2 dx. Now I know the integral of the natural log of x. That's equal to x natural log of x minus x plus c. Say that 5 times fast. Commit that to memory. The only issue I have here is that this is not just plain old x. Not a problem. All I have to do then is u substitution. So I'm going to let u equal 5x plus 2, which makes du 5 dx. And I can solve for dx, say that that's du over 5. Let's rewrite the integral now. That'll be 1/5, pulling that out front. 1/5 the integral of the natural log of u du. Now I can apply my formula just using u's instead of x's. And so this is going to be 1/5. And then apply my formula, u natural log of u minus u plus c. And of course I can't leave it like this, so I'm going to replace u with 5x plus 2. When I rewrite all that, I'll have 1/5 u times the natural log of u minus u plus c. And I could do some work to simplify that, but it's not going to make it any better. The only thing that I would remind you here is if I were to distribute this 1/5, and I ended up with 1/5 times c from right here. 1/5 times any constant is still just any constant, so this would just get rewritten as plain old c. Don't let that confuse you on a multiple choice test. The other formula that we learned is if I have a number raised to a function. Remember here in this case I've got the derivative of pi raised to the tangent of x. Pi is just a number, 3.14 something, it's just a number. Right? So I can use my formula. My other formula that I learned today is that the derivative of any number raised to x is just the number raised to x times the natural log of that number. Okay, so in this case, pi is my number. So a is pi. And so I can apply my formula here. So I have my number raised to x times the natural log of my number. And the only thing that's tricky about this one then is this is not just plain old x. So I have to follow a chain rule. I'm going to now multiply by the derivative of tangent of x, which is, I believe, secant squared of x. And so all of that then is my final answer. I could write it in a different order, but there's nothing I can do to simplify that one.